Here it is right here. As you can see, it's through the actuator. Alright, now what we'll do is we'll put this back down, we'll turn it on and check it out on this animal. Okay, now that we have the contact in place underneath, we still had a problem hearing that 16-foot note. So on a Farfisa, your keys look like this. You have 3 arms per key, and each key gets a plastic actuator, its own certain length of an actuator. So what we want to do is we want to pull that up, and in this case it's the 3rd one in the back. So I'm gonna bend it a little bit. Now I have that 16-foot footage in there. Just by bending that metal arm, because through fatigue from people hitting them and dropping them, they bend themselves. They bend lower. So what you need to do is pull that up so it pulls that contact up into position further. And that's part of the regulation of a Farfisa. Hopefully you'll never have to do this. So let's move on to the next one. Okay, here we notice we're on A flat now, G sharp. This is also missing the 16-foot, the bottom end. We've just looked underneath the keyboard, and it does not look like it's a contact issue. This looks like it could be a board issue. So we're going to open up the board now, and we're going to test the dividers and see where we are with them.
Alright, this is the G sharp board, and we've got our dividers, and they so far are all here. Yep, all the dividers are here, so it's not an issue that is a divider or board problem. If it's not a contact problem, it's not a board problem, the only thing left is the switch.
Well, maybe we need to re-examine the contacts again. Okay, here we go. We've realized that it actually is a key contact. We thought at first it wasn't, but upon further inspection, we realized it is. But since it's under this master board here, the tone center, we're going to have to remove this to get into those particular keys. Farfisa, it's not just a job, it's an adventure. Okay. Is there more missing? Here we go. Now this lifts right up. And you can see how you can get to the contacts a lot easier now. On a side note, underneath here, these are more contacts for each switch. So whenever you're under here, you're always going to want to maybe clean these with some good contact cleaner, each one. Blow the dust out. Okay, but back to our divider, our contact rather.
I think you turn it off.
Again, we've realized that it is a contact issue. So what we're going to do again is we're going to try bending that and see how we do. It's still hard to get to. it's not wanting to play ball with us. But when I was under there, I lifted it manually with my hand against the contact, and the note in the 16-foot did appear.
Alrighty, we're here on the A sharp chord. There was some confusion as to what note we were on, but the A sharp is showing 1 divider, 2 dividers, 3 dividers, 4 dividers, 5 dividers, and divider number 6 is not operating, which would be the lowest footage. Yes, the low note. So we're going to look at the schematic for this. There is the possibility that it is a transistor, and if so, we're going to be changing this. If not, this could also be a capacitor issue. We've had some of them fail as well, and whether they're coupling capacitors or on the other end. So this one does not appear to be running. That one appears to be. That one is there, and that one is there. Let's see. That one is sitting there. And that one is a base lead, okay. That's fairly close in approximation. Alright, so the problem is going to be in the last stage. We see something happening here. We're going to refer to the schematic and then make some measurements on the transistors. Power off, because ohm meters don't like voltage very well. Okay, now 150, it's germanium. 1292 does not sound right. That doesn't sound good for that transistor, I'm sorry to say.
But you're checking them in series.
Well, what we did is we checked them as 2 separate diodes. And now I'm going to yank them because I don't get a reading that makes much sense except for one of them. That's the C lead. No question about that. That's the B lead. And that was the E lead. Okay. Let's see what we get now. If you have one of these and it's got a little dot on the case, that's the collector. Alrighty.
So those are PNP.
.140. Come on. Give me a steady reading. 149. 140. That one actually reads good for germanium. Sometimes this is hard to do in the circuit because there are other little goodies that sit there and occur. leads look like they're corroded. As I said, this appears to have sustained water damage. $134, $149. That makes no sense.
Appears good too.
Yeah, but this whole section is corroded. You know, the problem with this may be a question.
We can put new ones in. We have a couple new ones.
Yeah, well, what we're going to do is, I don't trust these for some odd reason. I'd rather go with a couple of new ones. Okay, that's 4, 3, 2, 1, that, and that. Okay, so they're all accounted for. I think we'll go with two new ones, and we're going to see what happens. So there should be no change in frequency or note. Certainly, if the amplitude were off, I'd know that'd be the output. But I'm not happy with the readings I'm seeing in circuit. It appears I'm seeing something else patting it down. But the output was there was an output, but it was very low. And so we're going to change the 2 transistors and then apply power and see if we get any multi-vibrator action.